Lesson 1-4 Properties. In this lesson, we will learn, or you will learn, to identify properties of addition and multiplication and to use these properties to solve problems. Let's take a look at this example. Small objects like counters or beans can be used to model operations with whole numbers. The diagram at the right models the expression of 5 plus 3. Counting the number of counters in the group after addition shows 5 plus 3 is equal to 8. Okay? In the same method, let's model 3 plus 5. 3 plus 5 is simply this. You simply have 3 counters. Okay? And you add 5 more counters. If you notice, okay, the sum is also 8. You know this already. So when you talk about 5 plus 3, okay, 5, you start off with 5 counters, then you add 3 counters. And you do 3 plus 5, you start off with 3 counters, then you add 5 counters. The sum is basically the same. Okay? So the value for 3 plus 5 is obviously going to be 8. Okay, what do you observe about the values of 3 plus 5? Okay, we talked about that. They are the same. Okay, they're the same. And it says they work with a partner to write and solve other problems like A plus B and B plus A. Summarize your results. The sum of A plus B and B plus A would be the same as A plus B will be equal to B plus A. Okay? And let's look at the letter D. Investigate 3 times 5 and 5 times 3. If the sum of A plus B is equal to B plus A, as in letter C, then we can conclude that 3 times 5 is the same as 5 times 3. Or, if you put it into letters, A times B is equal to B times A. If you notice, 3 times 5 is equal to 15, and 5 times 3 is equal to 15, and they are the same. Which brings us to the properties that we've discussed last year. Okay, chart below shows summarize some of the properties of addition and multiplication. Let's talk about the commutative property of addition and multiplication. Okay, the commutative property of addition and multiplication simply states that if you have A plus B, it is the same as B plus A. Just like the example, 5 plus 3 is equal to 3 plus 5. This will make the sum the same. This will not change the sum of the expression. In the same manner, when you have 2 times 4 is the same as 4 times 2. So therefore, if we put it in variables, okay, we let A and B represent 2 and 4. A times B is the same as B times A. The commutative property of addition and multiplication. Remember, we discussed this last year, and when you talk about commutative property, we talk of the word commute, okay? And in the word commute, okay, the root word commute means to move. And if you notice, we just moved A and B into a different order. We moved the numbers or the variables, okay, so that the product will still come out the same. Next property we are going to review is the associative property of addition and multiplication. Okay, and in this particular property, we think of the word associate. Okay, the root word will be associate. And if you join a group, if you join an association, you are joining a group. So when you talk about associative property, you are grouping. Okay? You're grouping numbers or variables, and the product or the sum will also not change. Let's take a look at the associative property of addition. if you have 2 plus 4 plus 6, in quantity 2 plus 4, it is the same as 2 plus the quantity 4 plus 6. Using the order of operations, if you notice, 2 plus 4 is 6. Add 6 to that will give you 12. In this case, 4 plus 6 is 10. Add 2 to that, that'll give you 12 as well. So, the associative property of addition, simply saying that the way the addends are grouped does not change the sum. So in symbols, A plus B in quantity plus C is equal to A plus the quantity B plus C. Okay, let me get your attention and let me show you the difference between the commutative and associative property. Of course, the associative property has parentheses, but look at the order of the numbers or variables. 2, 4, and 6. 2, 4, and 6. The order does not change. A, B, C, A, B, C. The order does not change. The only thing that changes is the location of your parentheses. In the same manner, you can do this for multiplication. The quantity 6 times 3 times 7 is equal to 6 times the quantity 3 times 21. And using the order of operation, 6 times 3 is 18, okay, times 7, okay, will give you the same product as 6 times 3 times 7, which is 21. Okay, so 21 times 6, okay, will be the same as 18 times 7. Okay? And again, take note of the order. 6, 3, 7, 6, 3, 7, A, B, C equals A, B, C. The order does not change. Okay? The order does not change. In comparison to the commutative property, the order changes in the commutative property. Okay? Let's move on to the next property, and this property is the identity property of addition and multiplication. And these are the properties. For addition, anything that you add, okay, the sum of an addend and 0 is the addend. Okay? So basically what it's saying is that the addend will be identical to itself when you add 0. That's why it's called the identity property, because you have 6 and 6, okay, identical to each other. For any number A plus 0 will always be A, and that is in symbols. Okay? In the multiplication identity property form of multiplication, anything you multiply with 1 will give you the same factor. So the factor does not change. Okay? 6 will still be identical to 6 for as long as you multiply it with 1. And in symbols, A times 1 will always be A. So that is the identity property of addition and multiplication. Okay, another property that we are going to discuss, the last property in this particular section, is the multiplicative property of 0. This is also sometimes called as the 0 property. Okay, and the 0 property simply states the product of a factor and 0 will always be 0. Anything you multiply with 0, okay, will always be 0. Okay, so 5 times 0 is 0. 8 times 0 will always be 0. And these properties can be helpful when you find sums and products mentally. Take a look at example number 1. Find the value of each expression mentally. 7 plus 13 plus 15. 7 plus the quantity 13 plus 15. So to be able to do this mentally, you need to think of compatible numbers. What numbers go with each other? In this case, if you notice, if you add 7 plus 13, that will give you a round number, which is 30. So you group 17 and 13 together, and you add 15. So we have now 17 plus 13. Using the order of operations, we add 17 plus 13 first in our head, okay, and that becomes 30 plus 15, and then after that you simply add 30 plus 15. That'll give you 45, okay, and that's using the associative property of addition. Okay, if you notice again, the order changes in the associative property. 17, 13, 15 becomes 17. Sorry, the order does not change. 17, 13, 15 does not change. 17, 13, 15. And in letter B, 2 times 16 times 5, this time we are going to think about 2 times 5 together, which is an easy multiplication, which will give us 10. So we group 2 times 5 times 16. We first use the commutative property of addition. This basically skipped a step. So the first step should have been 2 times 5 times 16, which is the commutative property of addition. And then we group 2 times 5, okay, using the associative property, times 16. And then simplifying it further, 2 times 5 is 10, times 16 becomes 160. And that's how we use the properties in our head to be able to solve expressions mentally. Example number 2. On a recent tour, Elton John and Billy Joel visited Knoxville, Raleigh, Richmond, and Washington. Raleigh, Richmond, and Washington, D.C. The mileages between the cities are shown in the table below. If the equipment truck traveled from each city to the next in consecutive days, how many miles did it travel? So from Knoxville to Raleigh, North Carolina is 362 miles. From Raleigh to Richmond is 156 miles, and Richmond to Washington is 108 miles. So in consecutive days. So what is the problem is asking for the total of the mileages between the cities. Okay, so we simply rearrange and group addends, so addition would be easier. And if you notice, 362 and 108 should be compatible with each other. So we group 362, 108 using the commutative property of addition first, and then the associative property, 362 plus 108 plus 156. And we know that 362 plus 108 is going to be an easy add, 470. Bring down 156, which will give us 626. So the total mileage is 626 miles. Okay? Okay. Oh, we did that already. Okay. Let's do some algebra on this. Variables represent numbers, so the properties can be used to rewrite and simplify algebraic expressions. And in example 3, it's asking us to rewrite each expression using the commutative property. Remember the commutative property, okay? Order changes. So you have n plus 6 becomes 6 plus n. In 4 times s, it becomes s times 4. Okay? Example number 4, using the associative property and then simplify. Remember that the order does not change, so it remains at m plus 5 plus 4, but the parentheses is the one that changes, that moves. So you now have m plus 5 plus 4. Now you can simplify, apply 5 plus 4 to become m plus 9. Remember, m plus 9 cannot be simplified any further because we do not know the value of m. And for those of you thinking that m plus 9, okay, is m plus 9, sorry, change that. M plus 9 is equal to 9m. Let me assure you that it's not. Because let's say the value of m is equal to 2. If the value of m is equal to 2, this becomes 2 plus 9. And 2 plus 9 is not equal to 9 times 2. Because 2 plus 9 is 11, and 9 times 2 is 18. They can never be equal. So m plus 9 is not 9 plus m. Okay? And this is the simplified form of that expression. Okay? In the same manner, we have 3 times 7t. Okay, again, in an associative property, the order of the numbers do not change. So you now have 3 times 7 times t, regroup that, becomes 21t. Okay, so that is now the value or the simplified form of the expression 3 times 7t. In example number 5, we evaluate. Again, in evaluate, we do two things. Remember that. Evaluate simply means, okay, so when you evaluate, this means two things. First one is to substitute, okay, and the second after substituting is to simplify. So when you evaluate, these are the two things you need to do. So in this case now, we're given x times y times z, or xyz. Value of x is 2, y is 8, z plus 15. Substitute 2 times 8 times 15. Okay? And it says there mentally, and the thing to, in order for you to do this, you need to think about compatible numbers. Like for example, 2 and 15 go together, because if you multiply 2 times 15, you end up with 30, and it's easy to multiply. So 2 times 15 times 8, using the commutative property, the order now changes. And then using the associative property, you simply group 2 times 15 times 8, okay, becomes 30 times 8, which gives you 240. So using the properties will enable you to solve expressions a lot faster. And that's it. We've come to the end of the lesson. On Google Forms, type a summary of what you've learned by responding to the objective of the lesson, and type a question you might want to ask in class. Thank you.